Hello again from Skip, Victor Echo 6, Bravo, Golf Tango. Back with some more old IFR fun. Just when I thought I had this thing working, it surprised me, so I thought I'd share it with you. It's pretty wild. So in my previous videos on this repair job, in this picture you can see how the audio meter, the modulation meter was banging off the end and back again. And this is in the generator mode of the operation of this unit. The problem I have now is with a different twist, and it's in the receiver mode. So this is what it's doing now. It's in receive mode, and you can see both needles now rolling. Before it was just the modulation meter on the right. Now it's modulation meter and the frequency air meter on the left, bouncing back and forth. It's very strange, and the digital display is also doing it. The other crazy thing is that it takes almost an hour for it to act up. It's a thermal thing, and the case gets warm inside, and whatever is acting up, it takes that long for it to start going crazy. So the generator and the receive portion of this unit share the audio receiver board, so I thought I'd go in there and check the two voltages, try and find something that's common to both applications. I go up here and I look on the two voltages that are common to that signal. They appear to be rock solid. Oh, back to the drawing board. Oh, well, meter went to sleep, that's all. I thought I had something there for a sec, but no such luck. Okay, this is another test, one thing I never tried before. So, and we've got the generator going, and we're looking at the IFR. I'm not monitoring nothing. There's the two wires for the voltage. They were good before, but I'm just curious. It's been running for almost an hour now. It's not acting up. I'm curious when it does act up. Does the audio on the scope act up with it? It might help me isolate things. Up to this point, I've just been looking at the spectrum analyzer part of it, and the RF signal, it doesn't disappear. It stays solid, as does the audio. So I'm curious if the scope audio display will act up also. Maybe help me isolate things. I don't know. It's a mystery. So we shall see, I guess. Time will tell. Okay, so I came back in from outside, and it's acting up. So look what it's doing. The audio is going around with the bias on the scope or something is flinching. Now, if I would go over to the spectrum analyzer, I think I can do this here. No, that's the amplitude. Oop. Where are we at here? There we go. See, it has no effect at all. Oh, so there's something in the audio part. Oh. See if it'll bounce like that. Interesting. Okay, let's look for something else. Another thing is I ran a cable out of the demodulator output. I ran up to the scope, and you can see it bouncing too. So there's something there. Now I'm going to try. No, that won't work either. No, that's all there is. So something's affecting all this. I don't know what. Strange. Very strange. You can see it flickering there, both of them at the same time. Interesting, interesting. Okay. I'm going to try something here. I see it's still acting up like crazy. And what I'm going to do is, it took just about an hour for this thing to start acting up, and it was really slow. It slowly gets worse and worse, and this is about as fast as it acts up on. So what I'm going to attempt, I'm going to move this over here. Well, maybe not yet. Let's see what I'm doing here. Okay, shutting this off, turning this off. unplug it from here. Now, take this over here. This is where I do this because it's just easier way to take these things apart. Are we in view? Close enough. Take that out of there. Here. Put it up here. It's toasty warm. All right. We're hoping that the heat is still in here. If it is heat, I don't know. I'm just guessing. Got some ideas though. Enter. RF. That's still acting up. Okay. So what I'm going to do now, on the audio receiver audio card, I can get at the pot that's at the very input of this card. Let's see what it's doing. Glasses. Are we in view? Oh yeah. Okay, that's, I do believe right here. Oh, of course, it's not going to stay on there. And up on the scope, you see it's jumping. I don't have the darn thing triggered. You can see the reaction. It was jumping up and down like the rest of it is. So this is the input to the audio card. That tells me something. Now, the audio isn't being killed. So I'm curious. I'm going to see what they're doing here. I'm hooking up the voltmeter onto this pin. I want to see what the DC value is on this. You see that? It's 0 and it jumps negative every time it acts up. Something. That's the audio input of this thing. So, if where this comes from is the G4303. That's this one. I'm going to unplug. This one here, G4303, goes with a digital card. Okay, I unplugged the line that goes to the digital card. That affects the frequency or part of the meter. I get a sneaky feeling this is 10.7 card, and it is warm. It's like everything else, but okay. What if I unplug? Oh, I can't unplug the rest of it. It's going through the motherboard. Well, that tells me something. You know, I don't think it's the. I think it's in the 10.7. receive generator card, which is where the demodulator chip is. And as I sit here and wait for this thing doing things, it will slowly get worse and worse and worse. Interesting with that voltmeter way it's acting up there. Let's go over here. Yeah, same thing. Boy, that bias or the modulation is really going bonkers this time. So, what does that tell me? It's before the audio card. So, I guess the next step is now the 10.7 card. the RF demodulator, because that's the only thing that's really common to the modulation and the frequency air. It splits there out of the demodulator chip and goes two directions. One's audio for the modulation, the other is a 10.7, which goes to the digital card, and that's where it figures out the frequency air. I don't know, am I getting somewhere? Hard to say. We'll see. The next thing I tried was I unplugged the input to that 10.7 IF card, and as you see there's a kind of a jumper thing here, and up on the scope she's pretty steady. Oh, I got a sneaky feeling it's that card, all right. That'll be the next step, trying to figure out how it's working. Oh well, here we go. Okay, this is kind of a chore, pulling this thing out of here. Disconnect a bunch of jacks and try and keep track of what goes where. And put them over there. These out. Get in the way. See this one here. Let's put it on here. This on. Now, pull this out of here. It's just hard to get out of there. She's crammed it pretty damn tight. Now, get the module out here. There it is. Nice name. It's toasty warm. I doubt very much if I can get the hook back up again and still be acting up. We shall see. Got my doubts. 2 screws in the back. And how do we do this? Got a pry here, got a pry here. Pry there, pry there. Oh yeah, great. More shielding. Soldered onto the board too. Okay. So I'll see it fits in here like this. So I'm going to take this, it's got to plug in there like that. Somehow it plugs in here like this. Careful. Okay, remember. I think that's looking for J32. That's got to go in here. This other card. These two are going to plug in over here like this. This one here. Come on. Plug in here like that. This is number 11. That's on there. I know my finger is getting in the way, but what can I say? And this one is number 10, and that's up there. Yeah. Okay. So hooked up, I think. My piece of cardboard. And plug it back in. Let's see what it does here. We'll get the camera back here a ways. See what's going on. And it's working. It just figures out. Yeah. Whatever's thermal in that thing is working okay now. If it's thermal, that is. It's a tough one, I tell you. Well, onwards and upwards. Well, here we go again. And of course, I got the 10.7 IF module out and opened and laying on top, and of course it won't act up, so we're going to see if we can heat things up and See what happens with hot air gun, but I've tried this already and I've had no luck. I just thought I'd show you what I was attempting here, but yeah, I mean, it's hot, damn hot. And it's rock solid, of course. Crazy thing. Meters aren't bouncing at all. Oh, I'm not sure what the answer is here. It sure looks like it's coming from this module. I guess we'll have to keep trying things. So, I didn't really want to do this, but this will be the easiest to prove if that module is what's causing it. So I've got this whole one I've been working on, and now I've got this one over here. It's my standby. It's a good working machine, so I'm going to pull a module out of it and swap it out. Just to see if it is or not, because I don't know. It's the easiest thing to do. I hate taking this thing apart, but that's the way it's going to be, I guess. So, get this out of the way and open her up, have a look. Piece. Yeah, just like before. I'll sit on the ground. Probably not see it. Oh well, you get the idea. And here it is. So I'll pull the module of it and stick in this and let it run for a couple hours and see what happens. Stand by. So I got the two cards out, and this is what it looks like close up. So I swapped it out, got it inside the unit under test, and ran it for hours and hours, and it didn't help. It still acted up, so it's not the 10.7 module, I guess. This is one way of finding out. Okay, so I was off on a tangent here a little bit. Since the frequency air signal is developed or created inside the digital module, I decided to look into it. So I opened it up, I brought out some more wires, and first monitored the 12-volt supply. The negative 12 is kind of developed on all these boards with a Zener. There is a negative 12 volt from the main power supply, but it's again regulated by some Zeners. So I thought I'd look at it, and that didn't prove nothing after a couple hours of warming up and things still acting up. And then I took it apart one more time and put the wires onto the 5-volt supply just to see if it was something's common to all this. So I figured it might be power. It might be a power supply situation. So I tried that, but no luck. So we're back to the drawing board again. Finally, I got a break. First off, I had to figure out I got to figure out a way to get this thing heated up without having the cover on, so I could look at some parts. And I started doing this and that, and it finally gave me a clue. So this is how this went. Well, I didn't know if this was going to work, but I thought I'd try it. I threw a towel over this thing and let it sit for about 40-45 minutes, and lo and behold, it works. So this is a technique to get things to heat up on it for me. Okay, so I figured out a technique to heat this thing up so I can leave the enclosure off by putting a towel over it. It takes quite a while still to warm up and act up, but what I'm doing is I'm teeing in some RF lines and just seeing what is happening here. It's acting up right now. This is a 10.7 signal coming off the IF module. It's not acting up at all. So it's a puzzler. But I'm going to isolate it sooner or later. I've been trying cold spray and it doesn't do anything. I don't know. It's a weird one. So, anyways, that's the latest. Yeah, let me tell you a story about the cold spray. I bought a bottle of this stuff, and man, has it got expensive. Anyways, it's got this goofy top that you have to break a tab off. And, you know, in order for this so-called trigger to work well, I broke the tab off. I tried to get the trigger to work, and it just wouldn't engage. It just played around, so I messed around with it, and I finally got it squeezed in, and it locked on, and I'd swear I think I sprayed half the can out of it just into dead air. I couldn't believe it. What a waste. And like I say, the darn stuff's expensive anymore. Okay, this is kind of another thing that kind of clued me in. Is I was running this thing, and I wanted to play with the frequency on the generator a bit to, well, just simulate the, I want to look at the carrier frequency error bit change here and there. So I'll get into that. Setting. I was doing that there. And I was playing like this. See? And what made me look at it is, hey, this is, I'm changing the frequency. Like here, I'll go over and swing over the generator here. What I'm doing is I got this set up with a knob here. You can look on the display here. I'm doing this back and forth, just changing the kilohertz back and forth. And when I was doing that, I said to myself, you know, this is kind of what this thing is doing. Only, of course, I can't do it as fast, but same kind of idea. And I thought, is it frequency related? You know, so I said to myself, So I got looking at a few other points on the oscillator board itself to check things out. And I got clued in. Yeah, this is a part I didn't show you. I didn't record it. And the machine's off now and laying in pieces, but I kind of assembled it just to give you an idea. What I did with the cold spray, I was, you know, shooting it all over the place, and sometimes it worked, sometimes it wouldn't. But I noticed in this area is the most sensitive, so I inserted this piece of cardboard in here to isolate the circuit board right here, which is the interface card. Runs all the ribbon cables to the different modules. Right, this box right here is the low loop oscillator module, we'll call it. I can't remember the exact name, but it's something like that. Anyways, I noticed if I just took it here and went right there, just in this corner here, I barely had to touch it. It would start working properly. I had the blanket on the top of it, and it would heat up, and then it would start going crazy, and I'd just go in there. And it took like an hour for it to act up. I'd just give her a quick zit, and about a minute later, or not even that, half a minute later, it would start working right. So I knew just by the temperature change in this box, in this module, it had to be in there. And I was monitoring it. I had all things hooked up like this on the output of it, looking at the signal. It was fine. Frequency was good. Frequency I thought was good, but I think it was just reacting so quickly I couldn't see it on frequency. Plus the counter doesn't catch it fast enough, so that gave me a clue. So I figured I was on a path here of maybe getting this thing figured out, and I still had I pulled the module anyways out of this one, and I still had the other IFR laying beside me with the cover off. So I pulled this module out, and I swapped them out and ran it for a couple of hours, and it never acted up. So I knew I was on the right track. A little closer look up at the board. I'll show you again. This is there's the crystal. That seems to be temperature sensitive. The oscillator, and then that's the little varactor diode there. I'll zoom in a bit more. See if that works. Oop, of course. There. That little device, that little diode, that's the varactor. That's the main oscillator. That's just a buffer going output. And then the crystal itself, very magnetic. I don't think that's my screwdriver. Oh, maybe it is. Huh, weird. Okay, here's a schematic of it. I thought I'd give you a little description of what this is before I move on to the next part of the show here. So you can see the crystal. It's an 18 megahertz crystal, and a reactor diode that's parallel to it. It's what adjusts this thing to keep everything locked up. There's a PLL chip on the bottom left-hand side there, and it develops a voltage which goes up to the reactor, and you can see the reactor tuner voltage test point. That's where I'm going to be putting the voltmeter on and show you what this thing does. Anyways, it all anything to do with frequency change or temperature change or whatever have you, the voltage on that test point is what adjusts the reactor and tunes in the crystal. So this is where the problem was. Okay, this is what we're doing now. So we can see the generator there, and this is the test voltage coming off that test point for that VXO. It's the voltage, control voltage for that crystal. It's too high according to the manual. It should be between 1 and 4 volts, and I'm seeing it as high as 6. So I now have the fast loop module out of the IFR now laying on top. So of course it's cold. I'll come in a little closer here. And there it is. The circuit I'm dealing with is right here. You can see the crystal. That's the oscillator transistor, so on and so on. So what I do is I'm going to heat that up very lightly. I did it with a hot air gun, big hot air gun, just barely touched over the board. And it went nuts. So now you'll see it here. I'm going to make some room here. I'll show you what I'm doing here with this thing. I bought this new tool from Amazon. I always wanted one of these. Never really needed it until now. I got it in view. Yeah, you can see it's hot air. I got it set low, 154. It's supposed to be Fahrenheit? Darn it, I know. Anyways, it has very little nozzle, so I can really concentrate the heat. Now we'll swing down here again. You can see the meters. Yeah, I'll put it on there. Oh, I'm getting the glare off this. Nope. Try and get the glare out of the meter there. There we go. Okay, you'll see what I do here. I'm going to put a piece of cardboard. I want to separate the crystal from the oscillator transistor. You can see that, yeah. So I'll heat up the transistor, and you see the voltage is changing a little bit, but the IFR isn't going nuts. There's a reactor, and so on and so on. So it's just trying to do something. But watch now when I just touch the crystal with this little bit of air. See if it locked up on us. There it goes. Look at that. So is it the crystal or the oscillator? The crystal's very temperature sensitive. I mean, I barely put any heat on it, and the meter's going nuts. And you can see the VCO voltage over there, trying to control it. So I've got it narrowed down. I never dreamed it'd be this module. I didn't think it was going to be frequency related. I thought it was a voltage or something, controlling something else doing it. But like up to this point, I just couldn't find it anywhere. And I think we may have it beat. Oop, still going. And we'll touch crystal again. I mean, this thing's barely hot. It's, I can put my hand in front of it. It's not burning my hand at all. And I'm barely, so you can see that box would get hot, radiate heat inside, and it would just go crazy. So I think I found it. Oh yeah, at first I thought, okay, I have a bad crystal. It's aged and drifted way off frequency or something like that, and the PLL circuit can't pull it back. But if you remember saying on the previous video to take note of the voltage, it was on the tuning voltage, it was going right to 6 volts. Well, if you notice the reference Zener diode there, it's a 6.9 volt Zener diode. And the tuning voltage was going right to 6 volts, so it was running out of range. So I decided I'm going to put a larger Zener in there. I had a 7.9 volts, we'll say 8 volt Zener, and I decided I'm going to put that in there and try it. I can't take all the credit. I did see this online earlier, but they were talking about the module going out of lock. This module was not going out of lock, so it's kind of weird. Well, I was having too much fun. Murphy reared his ugly head one more time. Oh, brother. Anyways, I was going to replace that Zener, and I had varactor diode on my brain for some reason, and what I did, I put the Zener in place of the varactor. Now, that shouldn't have done nothing. I turn on the unit, the module goes right out of lock, red light comes on, and then all of a sudden I can smell something, and the whole unit goes dead. The main fuse is blown, and like, what? What did I do? I didn't do anything to cause this. I just don't believe it. So, like I said, Murphy raised his ugly head one more time. So this is the power supply. It's actually the battery charger board. The power supply is underneath all this inside this box, and it's a bit of a chore to get it apart. The worst thing is there's 7 or 8 feed-through points at the top of the board there that I got on solder, and then the bolts for the various FETs and transistors on the bottom plate, and one bolter gets right in the way of that transformer, and it's a bear cat to get, to pull that board out of there with that bolt stuck in there. So it's a struggle, but it can be done. So I got the power supply out of the box. It was inside this thing, and I had unsoldered all those feed-throughs, and that's the battery charger inverter, which isn't the problem. It's the actual power supply that's shorting out. So I've tricked it. I've got a power wire going in, and this is the ground wire I have to ground. It normally goes to the power switch in front of the IFR, but this thing has got a dead short in it now. So what I'm doing here, I've just got them hooked to a power supply, and I'm just doing this. And what you can see is when I do this, I'm in this power supply. Let me zoom in here a bit. Right now I got about 16 volts going into it, and it's being current regulated. So when I turn it on, you can see how I'm putting that wire to ground, and it's just drawing an amp of current, and it's sucking the voltage way down. So right now I've got the diode disconnected from the inverter, the chopper FET, I'll call it. So it's back before that in the other circuit. I cannot believe that something I did caused all this. I think this darn thing just decided to go. They're famous for it, but so I got this diode disconnected right in here, and it's in the control circuit, not the power side. So, well, we'll see, I guess. I don't know what else to tell you. Oh man, I've had a lot of fun with this contraption. So before I fully understood how this thing worked, I was looking for a short on the secondary side of the DC to DC transformer. And I was finding nothing. Everything seemed to be good, but I did find this capacitor, and I think it was the one that was causing all the trouble. It still measured good, but you can see in the bottom it was kind of burnt away, and it was leaking like crazy, so it's more likely the culprit. But I was still finding a short, and it's because I didn't understand how this thing worked. I do now. Well, I think I might have it running finally. I don't know. I got this board out, and I went through a lot of things, and it boils down to that one capacitor. You can see the green one and the blue one. Well, the green one is the one that went bad on me, that position. I put this one in. It's a different value. And the capacitor here is what it's on that positive 12 volt side, and it gets rectified, and it feeds it back into the other circuit, which creates a pulse width modulation. You'll see it here. And it sets it now. I swapped these two around to get the right value in there, and that seems to make all the difference in the world. Plus, I had to put a load on it. It's this has been a learning curve, this one. So I'll fire it up. Now, in order to fire it up, I have to put this line low. Now you can see over here, I got 12 volts, so that's correct. Now the negative 12 volt is a negative 16, and it depends on the load. And like I say, I'm just faking it here with these two resistors. The main oscillator, I'll see if I can get a little closer here. This is the switching FET. It goes into transformer itself. See if I can lock this up a bit. Wrong button. There we go. This looks a lot better. I had just a small spike. With no loads, this thing just goes into a dead short because it's trying to... it works on how much load. So this thing's all been designed around the 1200. And the 40 volt supply for the oscilloscope, it's good. Let's see if I can show that to you. Where am I at here? Yeah. Let's see if I can show. I'll take the... well, maybe I can't get the... Can't get it all on the same display? No. I'll try and get it here somehow. Anyways, there we go. I'll have to disconnect this lead. And now I don't have a... I should actually have a proper probe here, but I'll hook it up. It's at 44 volts now. Before it was 40 with a different resistor on it, but it's close. And the -5, which is a totally different circuit, it's good. It's at 5 volts. So I'd say this thing's working, but I'm a little, it's a big job to take this thing apart and put it all together again without changing that capacitor. The one, oops, oh boy, here we go. The one I've got in here is this blue one. It's a 470 microfarad, and they call for 330. This one I think is very critical. This one was bad. I stuck that in, and I think it had an effect on it. You read the book, and they talk about charging time and stuff like that, which gives the feedback into the oscillator circuit. So this on the -12, there's nothing like that. It's just pure filtering. So maybe it'll work. I don't know. But like I say, it's a bear cat to get this thing out of the box. A lot of unsoldering, a lot of bolts undo. In fact, is this getting warm? No. And so I might try and find the proper capacitor for it before I put it together again. But we shall see. This is the bad one. It still measures good, but you can see the inside. Well, it's not going to focus, but it's all burnt, and it was leaking like crazy in the bottom, so I think that was part of it. We'll see when I get it back into the machine, I guess, and go from there. So that's the fun part. Well, it's been quite a chore. I got more things on the workbench here than I know what to do with. It's been quite a battle getting this thing to work. But I think we may have it. I don't know. We'll see. I guess time will tell. So stuff scattered all over the place here. And that's the other good one. So we're learning. It's been a lot of fun. Anyways, this stupid thing. I got to admit that I sure am learning a lot about switching supplies and stuff like that and these things. I've always been a little scared of these dumb things, but once you get into them, they're not that bad. If you can figure it out, that is. You gotta have a darn a good schematic. Sure, it does a world of good. Anywho, that's next step is to get this thing together and see what happens. Okay, so I'm gonna put this thing back together again. I got some capacitors from DigiKey, and this is going into the negative power supply, so I go looking for the polarity on this capacitor. And of course there is no markings other than the long lead, and I'm thinking that's weird, and I see BP written on it. No, you idiot, I ordered the wrong capacitor. So I reordered, got the proper ones, 330 microfarad at 25 volts, a little smaller in packaging, but that's okay. But again, I got to make darn sure I get the polarity right, because this is positive. This is C8. Looking on the schematic here, C8 is positive ground. And of course, when I was unsoldering it, the foil came off. Oh, there goes the capacitor on the ground. When I was unsoldering it, some of the foil came off, so I'm not sure if the through-hole soldering is good, so I'm going to lift it above just a little bit. But anyways, it was negative, positive ground, so I'm just going to well, of course, put all my tools away. It's been a few days since I've been back at this thing, so I'm going to bend the positive lead over and connect it to the ground side, the ground foil on top. There's nothing on the bottom. If I cut it open there. I might have to trim it off later, but anyway, so negative goes on this side like that. So we'll go over here on this side, we'll get this soldered. Enough to pull this up through. There. It'll sit pretty. Trim this off. Just going to check again. Negative, positive to the ground. Yep, okay, we're good. Trim that off, go over here. And I'm going to take this lead. Just going to bend it over here a bit. There's a bolt hole here. Now, you know, foil always takes a lot of heat. So, get the other iron going here. It's got a bigger tip, a little bit hotter. Call it good. That should do it. That looks smaller, faster, but it's good. Positive ground, negative going to the hole. All right. We'll test this thing again. Yellow is positive. Get our leads on here. Put on this one. That's our positive lead. This one. That's our negative lead. This is the load. This thing will not run without a load. It just acts like a dead short. So I'm not sure what we're all looking at here, but I'll zoom the camera up here a bit and see if you can spot the, well, we'll do this in time. So this is the enable line, and it's got to go to ground. I'm going to make sure I get the right hook up here. Yeah, the power supply on there. Touch it. You gotta be kidding me. It's acting like a short. Well, I just don't bloody believe this. Back to the drawing board. Okay, I'm back. I'm not sure what was that all about. One thing I think of is one of my leads of my voltmeters was touching ground. Anyways, I got it all hooked up again. And I'll go up to the power supply. You'll see it. No, it's these two displays. I put about 18 volts, 16, 17, 18 volts, and we'll crank up a bit. And that's the current. So now I'm going to enable with the ground lead on the enable line. And there, it's going up to 5 amps. Before, well, the voltage cut back because of the full back on the current regulation, but it's working. It's not acting like a dead short. Now look at my power supplies. I got positive 12. It's regulated. This is the negative source for the negative 12, which is just a halfway rectifier. There's no regulation at all. It gets filtered or regulated on the boards by Zeners and such. So I've measured the 40 volt line on the board. It's right on 42 volts, so it's with no load, mind you. I guess the next step is I got to put it together and stick it in the IFR and see what happens. So that's the next step. Got to put it in there and see what happens. So onward and upward, I guess. Well, this has been a struggle. Well, okay, it's back together and it's all hooked up. I've got it, got load resistors on it. I got it tied up to the battery charger board. I just have to ground out one lead to, it acts like the power switch on the front of the unit. So I'm monitoring the 12 and the negative 12 lines. Again, negative 12 is not regulated. And we're still working up to the power supply up there. So, without any further ado, I'm still current limiting like crazy here. So, this is my power switch. Click it on. And things are looking good. Up in the power supply, you can see it's still around 18 volts and drawing just about 3/4 of an amp, which is an area I'm looking for. The 2 voltmeters Plus 12, that's regulated, and the negative 14, that's the unregulated supply. So no smoke. Things are looking good. The resistor's probably getting warm. Yeah, a little toasty. So I think we're laughing. I'm just going to unplug it and turn it off again. I'm going to watch my current regulation here. Try it again. Oh yeah, that's better. Jump straight up now. The kickback was starting to kick in there at the beginning. So I think we got her made. Put her back in the machine and we'll call it good, I guess. So, whew, what a battle this has been. Crazy darn thing. Anyways, that's it for this part. So, power supply's back together. Getting in this, back in this crazy box is the fun part. I probably won't be able to show you much, but it does fit in here. Oh, there's a lead here that's got to make sure it's out. That's the reference, 10 megahertz reference coming in. And somehow, oh, I see, got some cables in the way. There we go. What a setup. I'm hoping they just line up. These Allen screws go in there. Tie everything in. Yep, look at that. Almost like it's made to go in there. Okay. Now, this has got to go in. There's a plug here. Got to make sure I get this in the right way. It's got to go like that. So this cord goes off like this. It's got to go in like this. If you can believe it. Nothing's ever easy. Oh well. Screws. There we go. I don't have a screwdriver. Well, anyways, I'll get back to you when I get this back together again. Well, it's a test. Fingers crossed. Here we go. Oh, good sign. Good sign. Got lights coming on. How about the scope? And wait for it. The intensity's up. Yeah, there's the scope. Good. Display's on. Everything's laughing. So, I haven't got the board in this thing, the module that I was playing with when I started. So I want to look at the voltages now. We gotta. I don't know if we can get a display of this or not. We'll try. I've got to pre-mark things a little bit here. Okay. 12 volts is right here. Oh, got no ground. Helps to have a ground. Put it on here like this. Still glowing up here. Oh yeah, things are so light. Good. 12.21. I want to write this down. 12.21 for my notes. 12.21. Negative side. Negative 12.18. Isn't that amazing? Negative 12.81. Okay, we got 40 volts for the scope here. And 40.32. Amazing. Keep saying things like that. And then the 5 volt line is right. This one right here. 5.141. What did I say? 5.141. Okay. Now the voltage coming in from the AC side of things. I want to look at that. Just to write down things here. See. It is coming on pin 4 of that charger. Oh, I can't get at it. Oh, I can go on this on the fuse here. It'll work. It'll be the same thing. 24 volts, really? Well, that's interesting. It says 14 to 20 volts. Okay, so plus 24 volts in. We're off to the races. Things are back to shape, so I'm relieved. Now, put the module back in and get back to where I started, where all the trouble started. So, back to our previously recorded issue. So, the unit's working again, so I'm back to the problem I was fighting with when all the excitement happened. So this is the fast, slow loop module. And what I'm going to work on is the tuning voltage on the varactor diode for the crystal. So, here's the crystal. There's the varactor diode. Me and being stupid at what I did before was I replaced the varactor with a Zener, and then the power supply packed it in. Had nothing to do with it. Just good old Murphy. So what I've got to replace is this one. This is a 6-volt Zener. This is the phase lock loop chip, and it develops the voltage for the varactor to control the crystal. I measure the control voltage on this pin here, and it's at 5.89 volts, almost 6 volts. The Zener is only a 6-volt Zener, so it's running out of range. So I got a 7.9 volt Zener, I think it is. I'm going to pull this one out, put the new Zener in. Hopefully it'll get more range to tune the varactor for the crystal when things get hot. So that's the plan of attack. So we'll see. Let you know. Hey, I'm back. So I've got it hooked up again. Machine's running, luckily, and we're going to measure these voltages. So first off, I'm going to measure the Zener voltage. That is right here. We got 7.9. That's what that Zener is a 7.9 Zener. The varactor, now, the tuning voltage for varactors on this test by before was rated at 6 volts, 5.9 something. Or, yeah, I think that's almost 6 volts anyway. So I don't know. 5.7. So I got a couple of volts to play with for the varactor for this thing to heat up. So we'll see. Like I said, it's the temperature on that crystal that was making things go wild. So I'll put it back together, get the shield, the box on the loop, get it back inside, and I'm going to put it in. Well, I'll throw a towel over it for now, I guess, and then heat it up. Let it run for a couple hours, and here's hoping. Maybe I'll finally, well, end of this problem anyways. I mean, this thing's been loaded with so many problems. I can't believe it's been a real chore rebuilding this thing, but it's a lot of fun. Anyways, stay tuned. So one more test before I box this up and really give it a full-time test is I got the generator running again, and it's hooked into the IFR, and you can see the machine is working quite well. I'll zoom in here a bit. I've got the low loop module still on top, and we're looking at the varactor control voltage on that one test point on top of the board there, and it's sitting there hovering around 5.7 volts. What I'm going to do is hit it with the hot air gun on the crystal like I did before, and before the signal would drop in and out of the IFR, and now with the higher voltage Zener, hopefully it'll hold. Yeah, you can see it in the background here. It's still running. It's not very hot. Don't need it hot. But so there goes the crystal, and you can see the voltage on the control voltage going up, but the IFR is holding. The meters are not changing whatsoever. Before they were cutting in and out. So this is another part of the test here that shows me that hey, this thing is working. I think I got it built. Changing that Zener seemed to have done the trick. So we'll box it up and let it run all day and see what happens. So back to the module. So all these are cut short, nothing sticking out. Put it together. It's amazing. I guess they're depending on the shielding here to Oh, there's a plastic coating here, so that's why. Yeah, okay. I was wondering about that, if it was possibly a short. Oh. She's a snug fit. And I'll wind up like that. Put a hole in the back for the screws. Complete unit. Alright, gotta get her in the slot here. I've got to disconnect a few ribbon cables here that I had from before, so they go underneath. Move everything back. Get these cables out of the way. Plug this one, so it's going to be in the way. I think that's everything. Here. Slid in. I've got a cable being pinched. Nope. Right. Put the screws in. Cabling. Ribbon cable back in here. And make sure they're out of the way. That goes in here. And before I guess now we'll put in some J2. Lots of little cable to keep track of, I'll tell you. J4. J3. Here. One more here. I believe this is should be J5, yep. And this one's one more ribbon cable goes in here. And it looks like all of them. Yep, okay. Back over here like this. Plug her in for the best. So far so good. You betcha. Plug in our signal cable. And good so far. Looks like it's working. So I'm gonna run her for a while. I'm just gonna use a towel over it for now. See if she'll heat up. And give it a whirl. Well, that's it. We'll let her run. And see how it all goes. If she makes more than an hour, I'd say we got her fixed. So stay tuned. Well, it's been 2 hours and it's still working. There's no bouncing out any meters, and the digital display is solid, so I think I got it. I think we'll put it in this case and give it a try then from there. How warm is it? Oh yeah, it's toasty warm. Well, it would have acted up like an hour and a half ago easy. So it's it's doing its thing. So this is the unit all cased up. Got it back in this enclosure and been running it for an hour or so now, and it's working perfectly, just like it did before. So I think we've got it fixed. I'm hoping this is the last of them. There's been a lot of issues with this machine, so time will tell. Great little units, but I've had good luck with them. But what people tell me, they're famous for acting up. I don't know what to say. Anyways, that's it for this one. Thanks for watching. Before I head out of here, I thought I'd share some of the things that this poor machine had to be fixed. How can something have so many problems is wild to me anyways. But anyways, there's a list of them, and I think there's a few others too, but I just don't recall them exactly. It's been fun, but should be a good working unit now if it keeps working, that is. We'll see.